Right, so for question 1, we've got an electron moving vertically upwards with a certain speed into a uniform magnetic field of that strength, and that field is directed from left to right for the observer in eastward direction. Make a rough sketch of the trajectory of the electron when viewed from these 3 different directions. Right, okay. So let's start by sketching what's going on here. So the uniform magnetic field is from left to right, so like that, from us, and the electron is coming up directly upwards, like that, towards us. Okay, so it is perpendicular to the magnetic field. So as discussed in the first video, that means it is going to be a circle. We just have to figure out how the circle is oriented and which direction and what radius it is. Okay, so that's pretty easy. So let's start. Let's make our sketch first. So let's see, from our perspective we see an electric field from left to right, and this is eastward, right? We're told that is from left to right in eastward direction. So this is not electric, no, what's this? Magnetic field, not electric field, magnetic field. Okay, and we're told that this is also the eastward direction. Also not easier to just say than that is then north, in other words. Right. Okay, and the charge is coming up right at us, like that. So out of the page, so there's its velocity vector. Right, okay. So I can immediately say that V is perpendicular to B. So thus, FB is a centripetal force it acts as a centripetal force causing the charge to move in a circle. The circle of radius, let's say of radius r, and now we calculate what that r is. Okay, so that is, as explained, that means the magnetic force is just equal to mass times the centripetal acceleration. Good. And this is qvb is equal to mv squared over r. Right, so r is equal to mv over qb, and now we just substitute the values. Okay, mass for electron, I fit here, it's 9.11 times 10 to the minus 31 kilograms times the velocity, it's, what is it, 1.70 times 10 to the 6 meters per second. So we're working with 3 significant figures here, it appears. So the charge, okay, to 3 significant figures is that, or you can put the extra 2 there if you want. You want to have a big effect in this case. And the magnetic field strength is 0.350 Tesla. Alright, and if I had my calculator, I could calculate that. 1 second. Okay. Okay, so what do we have? 9.11 times 1.7 divided by 1.6 divided by 0.35 times 10 to the power. What do we have? Minus 31 plus 6 plus 19. Okay. Okay, so I'm going to give you the answer to 3 significant figures. That's all that we're really fairly confident about. So 2.77 times 10 to the minus 5 meters. Okay. So that's all good and well. So it's moving in a circle with this radius. So now we just have to sketch what the actual trajectory looks like. And now here we've got to think in 3 dimensions. Okay, so let's see. Let's use this picture and think and try to figure out how that circle is going to be oriented. You can use the, I suppose, the coin. You can bring a 5-franc coin with you if you really want to, if you think it'll help with these kind of questions. I haven't decided yet if I want to include that in the exam. Okay, so I know it's going to be a circle because I'm only considering the magnetic force, and the velocity is perfectly perpendicular to the magnetic field, so it is a circle. I just have to figure out how it's oriented. Okay, so now this is from my perspective. Let's see. Let's just write and rule. Okay, so velocity. Okay, so it's coming out like that, and ouch. Okay, so magnetic field is in that direction. So force upwards. Well, it would be if it was a proton, but it's instead an electron. So the force is downwards. Okay, so it is coming out of the page, and it's feeling a force in that direction, right? So it is going to be like that. Okay, so it's going to move like that. All right. So in other words, it's going to look like this. On the outside rim, if the circle's an outside rim of this 5 rand coin, then it's going to look like that from this perspective. Okay, so for A, it's just going to be a vertical line is all that we're going to see. Let's see if I have space. Okay, well, we can indicate the radius if you want. And then that is the radius R. Okay, okay. So how about B? Okay, what does B ask? B asks from the west. Okay, which would be the west side? Okay. Okay, that is north, that is east, so that's west. That's west. So someone looking from the west would see this. And I already figured out that it will move like this around the circle, like that. So what would this look like? What does this look like from that perspective? Now you've got to use your visual reasoning a little bit. This one's going to see, do you see that? Clockwise movement. So this guy is going to see clockwise movement of radius R. And it's going to go around at that initial velocity v. Okay, and for C from the east, it would be there. You can try for yourself, but you should see it's going to be anti-clockwise movement, right? It's moving like that. From this perspective, that is anti-clockwise. Okay, so you need to be able to reason a little bit visually for this kind of thing. Okay, and there it's going around at a certain velocity v, and it's in this circle with radius r. Okay, and that's it for question 1.